Hi, my name is Vincent, and today I want to take a look at dividing exponents with the same base. So we have the problem, simplify the following expression, and we're looking at 9 times x to the negative 3 times y to the second times z to the seventh, all divided by 3 times x to the negative 5 times y to the negative 4 times z to the 6th power. So now, the straightforward way to do this problem would be to use the division property for exponents, where when we have some a value not equal to 0, because remember we can't divide by 0, that would be undefined, we have a to the b divided by a to the c equals a to the b minus c. So when we're simplifying a division with exponents problem, all we need to do when they have the same base is subtract the exponent in the denominator from the exponent in the numerator. So we're doing b minus c, and we can simplify it into a single exponent expression. So using that concept for this question, the first way we could solve this problem, well, for the first piece, we could say 9 divided by 3 is simply 3. And now we're looking at x to the negative 3 divided by x to the negative 5. Well, using this exponent property, we have a to the b divided by a to the c. We're subtracting b minus c, or we're subtracting the exponent in the numerator and we're subtracting the exponent in the denominator. So we're doing negative 3 minus negative 5, just following this exponent property for division. So now we're going to multiply times y, and now we're using this property again, except now we have a b value of positive 2 and we have a c value of negative 4. So we're doing y to the 2 minus negative 4. And now our last piece will be times z to the 7 minus 6. Once again using this division of exponents property. So now z to the 7 minus 6. So this simplifies. We have 3 times x to the, well, we have negative 3 minus negative 5. So this 2 minus signs will turn into addition. Now we have negative 3 plus 5 is a positive 2. So we have 3x to the positive 2, or 3x squared. And now times y to the 2 minus minus 4. Well, 2 minus minus 4 turns into 2 plus 4 because we're subtracting a negative number. And now we have y to the 2 plus 4, or y to the 6th power. And then finally z to the 7 minus 6. 7 minus 6 is 1, so we have z to the 1st power, or simply z. So the next piece of this problem, this solution, the second way of solving this would be for the student that does not like working with negative numbers, which I find a lot of students don't like to use this property when there are negative numbers involved. So that's when we would use this property of exponents. When we have a to the negative b power, remember this is still for a not equal to 0. A to the negative b power equals 1 over a to the b. And now a simple explanation of what this property really means. Think if a to the b power means a times a times a times a, well then negative b is the opposite of b. So instead of multiplying by a times a times a times a, we're going to divide by a b times. So we're dividing by a, divide by a, divide by a, and we do that b times, so we get 1 over a to the b. So now we have 9x to the negative 3, y to the second, z to the 7th, divided by, and now we have 3x to the negative 5th, y to the negative 4, z to the 6th power. So we use this property, but now first I want to analyze one example where we do this in a dramatic fashion. So we're just going to rewrite 9 and 3, because we're not using this property on 9 and 3. But let's look at x to the negative 3 over x to the negative 5. And after we analyze this one a little bit more in detail, you'll see a fast, quick way to simplify this problem. Well, x to the negative 3 using this property here is equal to 1 over x to the positive 3, where x to the negative 5 is equal to 1 over x to the positive 5. And now when we divide two fraction terms, we could use that keep, change, flip technique. So we have 1 over x to the 3rd times, and now we're going to flip the fraction in the denominator to x to the 5th over 1. So now this simplifies to x to the 5th over x to the third. So notice what happened to this fraction here. X to the negative 3 got sent to the denominator as x to the positive 3, and x to the negative fifth got sent to the numerator as x to the positive 5. So when we're simplifying where we want to get rid of negative exponents, I'm going to send x to the negative 3 down to the denominator, and that'll swap out this negative and make it x to the positive 3. If we want to get rid of x to the negative 5, we don't like this negative 5, so we send it from the denominator up to the numerator. So this act of swapping it from the denominator to the numerator will make this exponent positive. So now, without doing any work for this piece, we're going to rewrite y squared because the exponent is positive, but y to the negative 4 we could send up to the numerator, and the act of sending it up to the numerator negates this negative 4, and now we have y to the positive 4. And finally, we could rewrite z to the 7th and z to the 6th because they're both positive. So we have z to the 7th divided by z to the 6th. So now we're working with all positive numbers, and when we simplify this, 9 divided by 3 is 3. We have x to the 5th divided by x to the 3rd, so we're doing this property, x to the 5 minus 3, which is x squared. And now we have y squared times y to the 4th. Well, y squared times y to the 4th is just y to the 6th. And now we have z to the 7th divided by z to the 6th. We're doing 7 minus 6 is 1. So, once again, we have the same answer, 3x squared y to the 6th times z. So, we have two options for solving this problem. You could choose either whichever one you like the most. This one is more to the point, but it's good to know how to swap out negative exponents and to change them into positive exponents by sending them from the denominator to the numerator or from the numerator to the denominator. Okay, well, this is going to conclude this division with exponents problem. Thank you all for watching, and I hope this video was helpful.